If technology could help visually impaired individuals detect obstacles and move more safely, today we are building smart blind goggles using Arduino Nano and an ultrasonic sensor that can detect nearby obstacles and provide instant audio alert. This Smart Blind Goggles project uses an ultrasonic sensor to detect the obstacles in front of the user and alert them using buzzer. As objects get closer, the warning frequency increases, helping users understand their surroundings more efficiently. Let's explore what's inside this RoboXCraft kit. Here, in this RoboXCraft kit, we can see goodies with some stickers. Then we can get the goggles here to assemble all the components in these goggles. And this is the Arduino Nano cable to transfer the code inside the Arduino Nano microcontroller. And here is the switch and the buzzers, and whenever the object gets closer, this buzzer brings sounds in the different frequencies. And here you can see the LiPo battery to power the Arduino Nano and other components. In this RoboXCraft kit, you can see different kinds of jumper wire. Here we have used the Arduino Nano as a microcontroller because of this smaller size and good quality. In this microcontroller, we assemble all the components and it receives the signals from the components and give output. Like whenever the object gets closer, the ultrasonic sensor sends signals to this Arduino Nano, and as an output, this Arduino Nano buzzes the buzzers and you can see here is our ultrasonic sensor. These ultrasonic sensors have the range up to 1 meter. Actually, whenever some detects or obstacles comes in front of this, there is one transmitter and one receiver. This transmitter transmit the ultrasonic wave, and the receiver, whenever that ultrasonic wave strike with the body, then it reflects and absorbed by this receiver. That's how it receives and sends the signals to the Arduino. Now here I'm going to make the blind goggles using Arduino Nano. Here we are using ultrasonic sensor, Arduino Nano, and the lithium LiPo battery. It is a 1500 mAh. First of all, we are going to connect this sensor with the Arduino Nano. In order for that, we need female to female wire. For female to female wire, we are using this 4 female to female wire. The VCC will be connected connecting, you can see this one is VCC will be connecting to the 5 volt. Here is the 5 volt. The GND will be connecting, the black one is GND, the GND will be connecting to the GND pin in this Nano. After that, we have trig. This trig will be connected to the D9. And echo will be connected to the D10. The last pin is echo. It will be connecting to the D10. Now we have successfully connected the ultrasonic sensor with this. Now we are going to connect the buzzer. There is in the buzzer there is positive. The long terminal is positive. We need one female to female wire again. Here we are going to connect the red is the male and this one is female. The red one will be connecting to the D3 pin, and the another negative terminal will be connecting with the GND here, Now we are going to connect this LiPo battery. In order to connect that LiPo battery, we need one male to female wire. This is the GND. The negative will be connected with the GND. Since we don't have extra GND, we are going to connect, or we are going to cut this and this one is the GND, and we can rotate this and put it like this inside here. Or you can do the soldering as well. Like this. After, we'll put to this GND. Like this GND is connected now. Now we have to connect this red one. We need one jumper wire, same male to female jumper wire. We are going to connect this red to the VIN. You can see the VIN is here. You can like this it will get power. After that, after this much of connections, we are going to put the code in this Arduino Nano. After here you can here we have uploaded the code. Now we are going to test, is it working with the code or not. Like suppose this is whenever I have code in such a way that whenever the obstacles comes at the distance of 50, it will buzz, and if the obstacles come closer in the range of 10 centimeter, then it will buzz loudly, like now, like this. Now you can see the working. Now it is not getting buzz. Now you can after working this project, now we are going to assemble all the components in this goggles. Here, as you can see, we have attached all the components in this goggles. Here you can see this pin is left, and we have to connect this pin to the VIN, because you can see this is the positive of the battery. So we have to connect this pin to the VIN to operate this smart goggles project. You can see here the working of these goggles is when the obstacles is at the range of 50 centimeter, it will buzz. like this, and when the obstacle come closer of the blind man, it will buzz loudly like this. It is the working mechanism of this. And you can see we have attached all the components like this. The buzzer is here, and like this.